students, how are you all? I hope that you all are good. As we know, the series of motion in a plane is going on and we have successfully finished the 14 lectures, right? So in a previous lecture that we had discussed about relative velocity, the concept of relative velocity. So what is relative velocity and what is tan theta, what is the direction of relative velocity, all these things that we have discussed in a previous lecture, and at the end of that lecture we have discussed some example problems. Okay, so now in today's lecture that we are going to discuss one more important concept, that is a man rain problems. Okay, man rain problems or man wind problems, man train problems, whatever it is. Okay, these concepts is also based upon relative velocity concept. Okay, so without doing any late, so we just start our lecture. Are you ready? Shall we start the lecture? Okay. So my name is Rakesh Karyanti. Welcome to our beautiful physics channel, Rakesh Physics. Right. So the first question of today's lecture is what? Have a look. A man at rest observed the rain falling vertically. When he walks at a 4 km per hour, he has to hold his umbrella at an angle of 53 degrees from vertical. So find the velocity of raindrops. So have a look what they are asking. Solution. So, whenever you are going to solve this type of relative velocity type of questions, okay, you must remember that velocity is a vector quantity. Velocity is a vector quantity. It has both direction as well as magnitude. Have a look. So, as we know that in a two-dimensional coordinate system, this is x-axis, negative x-axis, y-axis, negative y-axis, right? So I cap is the unit vector along positive x-axis, minus I cap is the unit vector along negative x-axis, and the j cap is the unit vector along positive y-axis, and the minus j cap is the unit vector along negative y direction. Also we consider that this is a east direction and this is a west direction, this is north and this is south directions. Okay, right. Shall we do the solution for this question? Have a look. A man at a rest. Initially, the man is at a rest position. Okay, and the rain is falling vertically, and he observing the rain. So the rain is falling vertically. That means the rain is falling like this. So what is this? This is the velocity of rain with respect to ground. Velocity of rain with respect to ground. Have a look. Just the observer observes the rain. It is falling vertically downwards towards ground with respect to ground. With respect to ground. So velocity of rain with respect to ground is equals to, have a look. They are not given the velocity, and I am considering the velocity of rain with respect to ground as v, and it is falling vertically downward direction, and it is falling vertically downward direction. What is the unit vector in a downward direction? Minus j cap. Minus j cap. Is it clear? Any doubts? Okay. Now when he walks at a speed 4 km per hour, he has to hold his umbrella at an angle of 53 degrees from vertical. Okay. So now he started moving. He started moving like this with a speed, velocity of man with respect to ground. How much? 4 km per hour. In this direction is moving. In this direction is moving. What is the unit vector along this direction? I cap is the unit vector. So this is the velocity of man with respect to ground. So when he is moving with a speed 4 km per hour in this direction, he has to hold his umbrella at an angle of 53 degrees from the vertical. And he is moving like this. Okay, so the rain is falling vertically. So he just hold his umbrella 53 degrees from the vertical. From the vertical, he is hold his umbrella at an 53 degrees angle and he is walking like this. Are you getting? So with respect to the vertical, so this is what? This is a vertical line. So with respect to this vertical line, he hold his umbrella. He just holds his umbrella at an angle 53 degrees. 53 degrees. Then what we have to find? Find the velocity of raindrops. So velocity of raindrops is equals to how much we have to find. Are you getting? Okay. So I'm just going to find out. Here we have velocity of rain with respect to ground, velocity of man with respect to ground. What we have to find? Velocity of rain with respect to ground is equals to how much? So for that, I'm using velocity of rain with respect to man. Velocity of rain with respect to man. That is equals to velocity of rain minus velocity of man. Velocity of rain with respect to man is equals to velocity of rain minus velocity of man with respect to ground. With respect to ground. Have a look. Velocity of rain with respect to ground. How much? Minus v j cap minus velocity of man with respect to ground 4 I cap. So what is this? Velocity of rain with respect to man. What we have to find? We have to find v value. V is equals to how much? Velocity of rain with respect to ground is equals to how much? So have a look. Here we got the velocity of rain with respect to man is equals to minus vj cap minus 4 I cap. That means from the center, have a look, minus 4 I cap. So what is the direction of minus 4 I cap? This is I cap, this is minus I cap, this is j cap, this is minus j cap. So minus 4 I cap is in this direction. Okay, this is what? Minus 4 I cap. So here we have minus vj cap minus vj cap. Now the umbrella is making an angle 53 degrees with the vertical. So this umbrella is making an angle 53 degrees with the vertical. If this is 53 degrees, if it is 53 degrees, have a look, have a look. If this is 53 degrees, then this is also 53 degrees. Are you getting? So this is a vertical line. So with respect to this vertical line, this umbrella making 53 degrees, opposite angles are same. Okay, right. So what we have to find? We have to find velocity of rain with respect to ground, that is minus vj cap is equals to how much? For that I'm taking tan theta. So from this triangle, so tan theta, is equals to what? Opposite side by adjacent side. So that is equals to, where theta is equals to how much now? 53 degrees. So tan 53 degrees is equals to, what is opposite side? This is theta, this is opposite side. If it is minus 4 I cap, this is also minus 4 I cap. So the opposite side is how much? The opposite side is equals to 4, and adjacent side along theta side we have v. We have what now? V. So opposite side, adjacent side. What is the value of tan 53? The value of tan 53 is 4 by 3, that is equals to 4 by v. 4 get cancelled out. From this we got v is equals to how much now? 3 kilometer per hour. What is this? This is the velocity of rain with respect to the ground. So this is the actual velocity of raindrops. How much? Velocity of rain with respect to ground is equals to 3 kilometers per hour. That's it. Any difficulty is there? Right, no difficulty is there. Shall we do that problem? Are you ready? Right. Have a look what they are given. A person moves due east at a speed 6 meter per second and feels the wind is blowing towards the south. Okay. So have a look. I'm going to draw the diagram based on given question. A person moves due east. So here is a person. So this person is moving towards east direction with a speed 6 meter per second. So velocity of man with respect to ground, how much? 6 meter per second. And he feels that wind is blowing towards the south. Wind is blowing towards the south at a speed 6 meter per second. So he is moving towards east direction and he feels that the wind is blowing towards south direction. So towards the south direction, the wind is blowing. So the velocity of wind with respect to, not a ground, with respect to man, because he feels that the wind is moving towards the south. So whatever the velocity of wind is there, that is the velocity of wind with respect to man. How much? 6 meter per second. So what they are asking, find the actual velocity of the wind. Question number A. What they are asking, find actual velocity. So actual velocity of wind means what ma? Velocity of wind with respect to ground. Velocity of wind with respect to ground. So velocity of wind with respect to ground means what ma? Velocity of wind with respect to man plus velocity of man with respect to ground. Have a look. The velocity of the wind is blowing towards the south direction. Along south direction, what is the unit vector? Minus j cap. Minus j cap. So the man is moving towards east direction. Then the unit vector is what? I cap. So just velocity of wind with respect to man, velocity of wind with respect to man, 6 minus j cap, minus j cap, plus velocity of man with respect to ground, 6 I cap. So finally we got velocity of wind with respect to ground is equals to 6 I cap minus 6 j cap. What they are asking? Actual speed or velocity. For speed, just apply magnitude on either side. So that is equals to square root of 6 square plus 6 square. So 6 square plus 6 square, 2 into 6 square under root. The square root can cancel out and 6 come out from the root, and the 6 root 2 meter per second is there. So velocity of wind with respect to ground is equals to how much one? 6 root 2. So in which direction it is blowing? If they are asked like this, in which direction it is blowing? So have a look. This is the velocity of wind with respect to man. So this is the velocity of man with respect to ground. From a parallelogram of vector, then the resultant is given by is in this direction. Okay, so this is 6, this is 6, and the angle made by vertical theta. So tan theta can be given by opposite side by adjacent side. Okay, so if we fulfill the parallelogram, okay, so this is 6, then this is also 6. If it is 6, if it is 6, then this is also 6. So opposite side 6, adjacent side 6. So tan theta is equals to 1. If tan theta is equals to 1 means what ma? Theta is equals to 45 degrees. So this is 45 degrees and it is east direction and it is south direction. So the relative velocity of rain with respect to ground is towards southeast direction. Towards southeast direction. Likewise, you have to do the problem. Are you getting? Any problem is there? Okay. So what is the second question they are asking? Have a look. If a person doubles his velocity, then find the relative velocity of wind with respect to man. So what happened? Same direction. In the same direction, the velocity of man with respect to ground is doubles. So 6, double for 6, 12 I cap. And the velocity of wind with respect to man is in this direction. So what they are asking? The relative velocity of wind with respect to man is equals to velocity of wind minus velocity of man with respect to ground. With respect to ground. So we have velocity of wind with respect to ground. So velocity of wind with respect to ground. How much ma? 6 I cap minus 6 j cap minus velocity of man with respect to ground 12 I cap. So 6 I cap minus 12 I cap. You will get minus 6 I cap minus 6 j cap. So this is what velocity of wind with respect to man. And if you wanted to find the magnitude, so velocity of wind with respect to man magnitude is equals to coefficient of I cap square plus coefficient. Again you will get 6 root 2 meter per second. So velocity of wind with respect to man. Are you getting ma? Any doubts? Right. Easy problems na? Okay. Just pause the video and write the solutions. Pause the video and write the solutions. 3, 2, 1, go. Right. Have a look. Example number 3. So what they are given in a question? A rain is falling vertically with a speed of 30 meter per second. Okay, sir. Based on given question, I'm just going to draw the diagram. Have a look. The rain is falling vertically downward direction. So velocity of rain. Okay, with respect to ground. How much one? 30 meter per second. Okay, sir. A woman rides a bicycle with a speed 10 meter per second in the north to south direction. North to south direction. Sir, you told you that. So this is north, this is south, this is east, and this is west. Now the girl is moving from north to south direction, sir. So now this is the direction of velocity of woman or girl with respect to ground. That is equals to how much? 10 meter per second. Are you getting? This velocity of rain with respect to ground and velocity of woman with respect to ground both are in a same direction. Now how can you find the relative velocity? What they are asking? What is the direction in which she hold her umbrella? In which direction she has to hold her umbrella to prevent her from rain? In which direction she has to hold? To do this problem, for my convenience, and just taking this is a north direction and this is a south direction. Sir, why you are taking this is north and this is south? Have a look. This is a north and this is a south and east west directions, right? So north is perpendicular to west, north is perpendicular to east. If I consider this is north and this is south, then these two sides are becomes east and it is west. Are you getting? Now what is the angle between north and west? 90 degrees. Now what is the angle between north and east? 90 degrees. Any changes there? No changes there. For our convenience, just we are considering this is the north direction and this is a south direction. Okay, no problem ma. You can take like this, you can consider like this, no problem. Okay, right, trust me, trust me. Okay, so when you got this type of problems, just consider this is a north direction and this is a south direction. Okay, right. Shall we do the problem? Okay, sir. Now, the rain is falling vertically with a speed, velocity of rain with respect to ground. How much? 30 meter per second. And a woman rides a bicycle with a speed 10 meter per second in the north to south direction. From north to south direction. That means in this direction, the velocity of woman with respect to ground. How much, ma'am? 10 meter per second. What we have to find? What is the direction in which she hold her umbrella? In which direction she hold her umbrella? Have a look. The rain is falling vertically in a downward direction. The woman is moving in this direction, okay, with certain speed. To prevent her from the rain, she has to hold her umbrella. She has to hold her umbrella by making certain angle, with respect to the vertical. Okay, with respect to the vertical. Have a look, rain is coming, the woman is moving like this. What happened? To prevent her from rain, she has to hold her umbrella by making an angle theta with the vertical. So now this angle we have to find. Are you getting any doubts? Okay, sir. Now to do this problem, so I'm just taking velocity of rain with respect to ground. Velocity of rain with respect to ground. So velocity of rain with respect to woman plus velocity of woman with respect to ground. Velocity of woman with respect to ground. We have the value of velocity of rain with respect to ground. How much? 30. In this direction, in a downward direction, what is the unit vector? Minus j cap. Minus j cap. That is equals to velocity of rain with respect to woman. We don't know. We have to find. So velocity of woman with respect to ground. She is moving in this direction. So 10. What is the unit vector in this direction? I cap plus I cap. Okay. So I cap. So velocity of rain with respect to woman is equals to minus 30 j cap minus 10 I cap. Okay. Velocity of rain with respect to woman is equals to minus 30 j cap minus 10 I cap. So this is we got. So have a look. Minus 30 j cap is in this direction. Minus 10 I cap. This is plus 10 I cap. So minus 10 I cap is in this direction. Minus 10 I cap. Okay. So this is what? This is an umbrella. If I extend this line, like this. This is umbrella vertical line. Angle between them theta. This is extended umbrella's line and this is vertical. Now what is the angle between them? Theta. Same. What we have to find? We have to find this angle. If we find this angle is equals to this angle. I'm just going to find this angle. So to find this angle, we have the formula. What is that? Tan theta is equals to opposite side by adjacent side. Then tan theta is equals to opposite side. What is the opposite side for theta? This is the opposite side. If it is 10, then this is also minus 10 I cap. So what is the value of opposite side? 10 divided by what is the adjacent side? So along theta side we have 30. So 0 0 cancel out. Then tan theta is equals to, we got how much mark? 1 by 3. So this value tan theta is equals to 1 by 3. In case of tan, the value of 1 by 3 is nearly equals to 18 degrees. Tan 18 degrees is equals to nearly. You will get the value of 1 by 3. So tan get cancelled out. Then theta is equals to 18 degrees. Theta is equals to how much more? 18 degrees. She has to hold her umbrella with vertical by an angle 18 degrees. Are you getting? Any doubts? Any difficulties there? Easy problems now? Okay. Shall we do that problem? Okay, sir. Right. Very good. So what they are given? A man walking at a rate of 3 kilometer per hour. The rain appears to fall vertically. The rain appears to. Have a look. Solution. I'm just going to draw the diagram based on given question. A man walking at a rate. A man walking at a rate. Velocity of man with respect to ground. How much? 3 kilometer per hour, because he is walking on the ground. Okay. Now, the rain appears to fall. The rain appears to fall when he is moving with 3 kilometer per hour vertically. That means velocity of rain with respect to man, because he appears to the rain is falling vertically. I don't know the velocity of rain in this condition, so I'm just considering the velocity of rain as v. What is the unit vector along this direction? I cap. What is the unit vector along this direction? J cap. So velocity of rain with respect to ground, that is equals to velocity of rain with respect to man plus velocity of man with respect to ground. We know about this formula, how to write. Okay, so that is equals to vrm. So vrm value is how much? Minus vj cap in a downward direction. The unit vector is what? Minus j cap, downward direction, plus vmg, velocity of man with respect to ground, 3 I cap. So this is the velocity of rain with respect to ground. Okay, just keep it aside. Okay, sir. Right. So in a case 2, when he increases his speed to 6 kilometer per hour, it appears to meet him at an angle of 45 degrees with the vertical. Find the value of velocity of rain. Okay. So what happened? At this time, the person increases his speed. Velocity of man or person with respect to ground is equals to 6 kilometer per hour. So I cap is the unit vector along that direction. Okay. So now, when he increases his speed, the rain is appears to meet him at an angle of 45 degrees with the vertical. That means, have a look. When he increases his speed, so what happened? The rain hits him. The rain hits him. Velocity of rain with respect to man at an angle 45 degrees with the vertical. 45 degrees with the vertical. Okay, are you getting? Now, in this case, I'm just going to find the velocity of rain with respect to ground. So what they are asking, find the value of velocity of rain. So the velocity of rain with respect to man is in downward direction. So along this direction, minus j cap is the unit vector. Now, in this condition, I'm going to find the velocity of rain with respect to ground. So velocity of rain with respect to ground is equals to velocity of rain with respect to man plus velocity of man with respect to ground. So velocity of rain with respect to ground, already we have how much? Minus vj cap plus 3I cap. So I'm just substituted this value here. Okay, so minus vj cap plus 3I cap. Excuse me. So this is equals to vrm, velocity of rain with respect to man, we don't know, plus vmg is equals to how much, 6I cap. Right. So velocity of rain with respect to man is equals to, so bring this 6I cap to this side, it becomes minus vj cap plus 3I cap minus 6I cap. Okay, plus term went to this side, it becomes minus. So velocity of rain with respect to man is equals to minus vj cap. Here minus 6I cap is there, plus 3I cap is there. Minus 6 plus 3, minus 3I cap. Overall, velocity of rain with respect to man is equals to, we got minus 3I cap minus vj cap. Minus 3I cap minus vj cap. So from this, have a look. This is the velocity of rain with respect to man when he is moving with a speed 6 kilometer per hour, and it is appears to meet him at an angle 45 degrees. If this is 45 degrees, then this is also 45 degrees. Now what is the value of vrm? We got minus 3I cap minus vj cap. So this is what? Minus 3I cap. Along this direction, we have the value minus vj cap, minus vj cap. So what we have to find? We have to find out v is equals to how much? Velocity of rain is equals to how much? We have to find out. So have a look from this diagram. From this diagram, we can write tan theta. We can write tan theta, that is equals to opposite side. So if this is minus 3 I cap, then this is also, so what is this? So this is what VRM. Okay. Now this is minus 3 I cap. If this is minus 3 I cap, then this is also becomes minus 3 I cap. So adjacent side already we have minus Vj cap. So tan theta is equals to opposite side by adjacent side. What is opposite side? The side which is opposite to an angle theta. What is that? 3. What is adjacent side? The adjacent side is V. Theta is equals to how much? 45 degrees. Tan 45 is equals to 3 by V. What is the value of tan 45? 1. So 1 is equals to, we got 3 by V. From this, velocity of rain is equals to V into 1. V is equals to 3 kilometer per hour. So we got rain, velocity of rain, which is falling vertically in downward direction. How much? 3 kilometer per hour. Are you able to see the board? Okay. So this is the velocity of rain, which is falling in vertically downward direction. Is it clear? Any doubt? Right. Just pause the video and write the solution. Pause the video and write the solution. 3, 2, 1, go. Right. So have a look. What is the example number 5 they are given? When a man is standing, rain drops appears to him falling at an angle 60 degrees from the horizontal from his front side. Okay. So have a look. I'm just going to draw the diagram. Solution. Initially, the man is standing. Okay. Now the man is at a rest position with respect to ground. Velocity of man with respect to ground is equals to how much? 0. At this time, raindrops appears to him falling at an angle 60 degrees from the horizontal from his front side. So with respect to horizontal, okay, na? With respect to horizontal, the raindrops are falling at an angle, how much? 60 degrees from the horizontal. So with respect to horizontal, the raindrops are falling by making an angle 60 degrees towards his front side. What is this? Velocity of raindrops. With respect to man. And why I am taking velocity of rain with respect to man? So because the raindrops appearing him, he is appearing there. So the raindrops are hitting me at an angle 60 degrees when I was standing. He feels like that. So that's why I am considering this velocity as velocity of rain with respect to man. So have a look in this condition. So I don't know the velocity of rain with respect to man. So I'm just considering velocity of rain with respect to man as a V1. So velocity of rain with respect to man is equals how much more? V1. Have a look. This V1 is making an angle 60 degrees with the horizontal. And it has both x component as well as y component. Have a look. So this is a V1 and it is making an angle 60 degrees with the horizontal along theta side. V1 cos 60 and perpendicular to this V1 sin 60 degrees along this direction. What is the unit vector? Minus I cap. Along this direction, what is the unit vector? Minus j cap direction. Now overall velocity of rain with respect to man is equals to minus V1 cos 60 I cap minus V1 sin 60 j cap. So from here, velocity of rain with respect to man is equals to minus V1. What is the value of cos 60? 1 by 2 I cap minus V1 sin 60 root 3 by 2 j cap. So what is this? This is velocity of rain with respect to man when he is standing. Now if you want to find the velocity of rain with respect to ground. So velocity of rain with respect to man plus velocity of man with respect to ground. In this case, velocity of man with respect to ground is equals to how much, ma? 0. So velocity of rain with respect to ground is equals to, we got minus v1 by 2 I cap minus v1 root 3 by 2 j cap. So this is what velocity of rain with respect to ground. Are you getting any doubts? Okay, sir. So this is what case number 1 when he is standing. So in a second case, what happened? When he is traveling at a 5 kilometer per hour on a horizontal road, they appears to falling on him at an angle of 30 degrees from the horizontal from his front side. So now what happened in a second case? Now the person is started moving. Now the person is started moving on a horizontal road. On a horizontal road with a speed. With a speed. How much? 5 kilometer per hour. Velocity of man with respect to ground. How much? 5 kilometer per hour. At this time. At this time. They appears to falling on him at an angle of 30 degrees from the horizontal. Now with respect to the horizontal. Okay, so here is a person. He is moving with a velocity 5 kilometer per hour. So when he started moving, the raindrops are hitting on his front side with an angle 30 degrees with the horizontal. So at this time, velocity of rain with respect to man, and considering as a V2. And considering as V2. Okay, right. Have a look. At this time, velocity of man with respect to ground is equals to in this direction. In this direction, what is the unit vector? Phi I cap. So this is the horizontal. Okay. So this is the velocity of rain with respect to man. How much? Velocity of rain with respect to man is equals to V2, and it is making a 30 degrees with the horizontal. Along theta side. Along theta side, you will get V2 cos 30 degrees in this direction. What is the unit vector? Minus I cap. Are you getting? Right, very good. So now in this direction, perpendicular to this, you will get V2 sine 30. In this direction, what is the unit vector? Minus j cap. Now overall, velocity of rain with respect to man is equals to minus V2 cos 30 I cap minus V2 sin 30 j cap minus V2 sin 30 j cap. So velocity of rain with respect to man is equals to minus V2 cos 30. What is the value of cos 30? Root 3 by 2 I cap minus V2 sin 30. What is the value of sin 30? 1 by 2 j cap. Are you getting? So this is what velocity of rain with respect to man. Now what we have to find? Find the actual speed of the rain. Find the actual speed. Actual speed means what? Velocity of rain with respect to ground. In this case, velocity of rain with respect to ground means velocity of rain with respect to man plus velocity of man with respect to ground. So that is equals to what we got, velocity of rain with respect to man minus V2 root 3 by 2 I cap minus V2 by 2 j cap plus Vmg plus 5 I cap plus 5 I cap. Are you getting, ma? Any doubts? Right. So from this, here plus 5 I cap is there. Are you able to see the board? Okay. Okay, now it is good. So here we have, I'm just written VRM value here and velocity of man with respect to ground value here. Okay. So here I cap is there, here I cap is there. So velocity of rain with respect to ground, if I take I cap common, here we have 5 plus 5 minus V2 root 3 by 2. V2 root 3 by 2. Okay. So minus V2 by 2 j cap minus V2 by 2 j cap. Are you getting any doubts? Let us say this is equation number 1, this is equation number 2. I'm just going to compare equation 1 and 2. I'm just comparing equation 1 and 2. Have a look. VRG cancel out. Here I cap is there, cancel out. So at the place of minus V1 by 2, we have 5 minus V2 root 3 by 2. I'm just comparing equation 1 and 2. Have a look. Here minus is there. Minus is there. Here j cap is there. Here j cap is there. V1 root 3 by 2. V1 root 3 by 2. This is equals to V2 by root. V2 by 2. V2 by 2 is there. Okay, get by 2. So 2 get cancelled out and V2 is equals to, we got V1 root 3. V2 is equals to how much more? V1 root 3. Just substitute V2 value here. Substitute V2 value here. So minus V1 by 2 is equals to 5 minus, what is the value of V2? V1 root 3 into root 3 divided by 2. So minus V1 by 2 is equals to 5 minus V1 root 3 into root 3, 3 divided by 2. If minus 3V1 by 2 comes to this side, it becomes plus 3V1 by 2 minus V1 by 2 is equals to 5. So 3V1 minus V1, you will get 2V1 by 2 is equals to 5. So 2 get cancelled out and V1 is equals to 5. V1 is equals to 5 we got. Substitute V1 in equation 1. V1 in equation 1. So in this equation 1, substitute the value of V1. So velocity of rain with respect to ground is equals to minus, what is the value of V1? 5 divided by 2 into I cap minus V1 5 root 3 by 2 j cap. Okay, so just find the magnitude. So velocity of rain with respect to ground is equals to under root of 5 by 2 whole square plus 5 root 3 by 2 whole square. Okay, so 5 square, what is the value of 5 square? 25 divided by 4 plus 5 square, 25 divided by 4 into root 3 whole square, it becomes 3. So 25 3 is 75 divided by 4. So this is equals to, you will get 25 by 4 plus 75 by 4. So denominators are same, numerators will be added. So 75 plus 25, 100 divided by 4, 100 divided by 4, it becomes 25, root over 25. So what is the value of root over 25? 5. So you will get the velocity of rain with respect to ground is equals to 5 meter per second. So what is the actual value of rain? Velocity of rain with respect to ground is equals to how much more? 5 meter per second, and this is your answer. This is your answer. Any difficulty is there? So process is very lengthy now. You want shortcut? Okay. So I will tell you the shortcut. So please pause the video and write the notes. Pause the video and write the notes. 3, 2, 1, go. Let's see the shortcut. Okay. Have a look. So according to given question, shortcut method. So when a man is standing, the rain appears to him falling at an angle 60 degrees from the horizontal from his front side. Okay. So I'm taking two-dimensional coordinate system. So I'm considering initially the person is at a rest and standing at this position, initial position. At this time, he feels that the raindrops are hitting him at an angle 60 degrees. At an angle 60 degrees. Okay, right. So what is this? Velocity of rain. Initially, the rain hit him at an angle 60 degrees. At an angle 60 degrees. Horizontal from his front side. So have a look. Horizontal from his front side. This is a horizontal line now. Okay. Now, when he is traveling at a speed 5 km per hour on a horizontal road. So now he started moving. Now he is started moving. So velocity of man is equals to how much? 5 km per hour. So now what happened? Now this is what? Velocity of rain. This is what? Velocity of rain. And the man is moving in this direction. The man is moving in this direction. Have a look. In a subtraction of two vectors, I told you that if this is A bar vector, this is A bar vector, and this is B bar vector. Okay. And if you want to find a subtraction, just we have to take the negative vector for B bar vector. Then the resultant. Have a look. Initially, the angle between A bar and B bar vector is theta. Now, what is the new angle between A bar and B bar vector? 180 minus theta. Now the resultant of these two vectors is given by resultant is equals to A bar minus B bar. Okay. And if you wanted to find angle made by the resultant with an alpha degrees with horizontal line is given by B bar sin theta by A bar minus B bar cos theta. A bar minus B bar cos theta, where theta is the angle between A bar and the B bar vectors. A bar and new B bar vectors. This is. So this is what we are discussing in subtraction of two vectors. Have a look. So along the direction of A, we have Vm. Along the direction of B bar, we have Vr. Now what is the angle between these two? What is the angle between these two? So have a look. Here we have 60 degrees. This total angle is 180 degrees. This total angle is how much, ma? 180 degrees. Okay. So from here to here, 60 degrees. Then what is the remaining angle? 180 minus 60. How much it is? 120 degrees. How much it is, ma? 120 degrees. Now the angle between Vm and Vr, theta is equals to how much? 120 degrees. It is clear. So next, have a look. Now what is the resultant of these two vectors? So the resultant of these two vectors is given by velocity of rain with respect to man. Velocity of rain with respect to man is equals to magnitude of Vr minus Vm. Vr minus Vm. Now, when he started moving with 5 kilometers per hour, so the raindrops makes an angle 30 degrees, makes an angle 30 degrees with the horizontal. Now, what is the value of alpha? 30 degrees. Alpha is equals to 30 degrees. Okay. Now, just use this formula. You will get B bar vector. At the place of B, we have rain. What we have to find? Speed of the rain. Speed of the rain. That's it. So tan alpha is equals to B bar means velocity of rain sine theta divided by A bar. At the place of A bar we have Vm minus Vr cos theta. So tan alpha, so tan 30 degrees is equals to Vr, velocity of rain. How much? We don't know, we have to find. Sine theta is equals to 120 degrees divided by velocity of man 5 minus velocity of rain. We have to find cos theta, cos 120. Okay. So what is the value of tan 30? The value of tan 30 is 1 by root 3. That is equals to Vr. What is the value of sine 120? Sine 90 plus 30, cos 30. Cos 30 value is root 3 by 2 divided by 5 minus Vr cos 120, cos 120, cos 90 plus theta minus sin theta, minus into minus plus sin 30 1 by 2. It is the value of sin 30 1 by 2. Just bring this term to this side. So denominator comes to this side, it becomes numerator. So 5 plus Vr divided by 2 is equals to, if this term went to this side, it becomes Vr root 3 into root 3. 3 divided by 2. Okay. So what we need, we have to find Vr value. Okay. So 5 is equals to, just to bring this Vr by 2 to this side, Vr by 2 to this side. Already here 3 Vr by 2 is there. So 3 Vr by 2 minus Vr by 2. So 3 Vr minus Vr. 2 Vr divided by 2. 2 to get cancelled out. So velocity of rain is equals to, we got 5 kilometer per hour. So this is the shortcut now. So by using subtraction of two vectors concept. Okay. Any problem? Okay. Pause the video and write the solution. Right. 3, 2, 1, go. Right. So this is another given question. So what is that? So here the rain is falling. The rain is falling with a speed 50 kilometer per hour by making an angle 53 degrees with the horizontal. So with respect to horizontal, the velocity of rain is how much? 50 kilometer per hour. Okay, sir. Now here a person is moving on an inclined plane. He is moving in an inclined plane with a speed 100 kilometer per hour. So what is the angle of inclination? 37 degrees. So he is moving like this. So what they are asking, find the angle made by the umbrella with vertical. We have to find at what angle he has to place his umbrella with respect to the vertical to prevent him from the rain. Okay, that is the given question. So please pause the video and try the solution. Pause the video and try the solution. 3, 2, 1, go. Right. I am going to solve the solution. Have a look. Whatever the rain is falling, whatever the speed of the rain they are given, that is velocity of rain with respect to ground. So velocity of rain with respect to ground. How much? So this one, this part. Have a look. So this is the velocity of rain. Okay, how much? Velocity is equals to 50 kilometer per hour and it is making 53 degrees with the horizontal. Now along theta side, velocity of rain with respect to ground. Along theta side, you will get velocity of rain with respect to ground cos 53 degrees and perpendicular to this and perpendicular to this. So we get velocity of rain with respect to ground sine 53 degrees. Sine 53 degrees. Along this direction, what is the unit vector? Minus I cap. Along this direction, what is the unit vector? Minus j cap. So we got velocity of rain with respect to ground is equals to velocity of rain with respect to ground. How much? 50 kilometer per hour. So 50 cos 53 degrees minus I cap minus VRG, velocity of rain with respect to ground. How much? 50 sine 53 J cap. Okay. So I'm just divided this velocity of rain with respect to ground into rectangular components. So I got this one and this one. So that is equals to minus 50. What is the value of cos 53? The value of cos 53 is 3 by 5 I cap minus 50 sin 53 value 4 by 3 j cap. Sorry, 4 by 5 j cap. Okay, 4 by 5 j cap. So 5 ones are 5 tens are 5 ones are 5 tens are. So that is equals to minus 3 tens are 30 minus 30 I cap minus 4 tens are 40 j cap. So this is what velocity of rain with respect to ground. Next term, if he comes to man, okay, if he comes to man, so this man is moving on an inclined plane. He is moving on an inclined plane at an angle 37 degrees with the horizontal. So what is the speed of this man? So velocity of man with respect to ground, how much? 100. Okay, na? 100 kilometer per hour, whatever it is, 100 kilometer per hour. So now again we have to resolve this velocity of man with respect to ground into rectangular components. So along theta side. So velocity of man with respect to ground along theta side 100 cos 37. 100 cos 37. This direction I cap plus I cap and perpendicular to this plus 100 sin 37 j cap. Are you getting? So 100 along theta side 100 cos 37. This is a I cap direction and perpendicular to this 100 sin 37. Along this direction, what is the unit vector? J cap. Both are plus. That's it. Any difficulties there? Right. So velocity of man with respect to ground 100. What is the value of cos 37? 4 by 5 I cap plus 100 sin 37. What is the value of sin 37? 3 by 5 j cap. 5 ones are 5 20s are. Okay na? So 5 ones are 5 20s are. So velocity of man with respect to ground is equals to 24 are 80 I cap plus 23 are 60 j cap. So this is what velocity of rain with respect to ground, and what is this velocity of man with respect to ground. What we have to find? We have to find angle made by an umbrella with vertical. To find that, I am going to find velocity of rain with respect to man. So you will get velocity of rain with respect to ground minus velocity of man with respect to ground. So that is equals to velocity of rain with respect to ground minus 30 I cap minus 40 j cap minus 40 j cap. So minus 80 I cap minus into plus minus 60 j cap. I am written directly ma. Okay. So velocity of RG minus VMG, velocity of man with respect to ground, So minus into plus minus into plus minus. Okay. So that is equals to minus 30 I cap minus 80 I cap minus 110 I cap minus 40 j cap minus 60 j cap minus 100 j cap. So this is what velocity of rain with respect to man. And if you wanted to find a angle made by the umbrella with vertical. So we have to use what, ma? Tan theta. So tan theta is equals to what? Component of y divided by component of x. What is the component of y? 100. What is the component of x? 110. So 0 0 cancel out. So tan theta is equals to 10 by 11 and theta is equals to tan inverse of 10 by 11. So this is the angle made by an umbrella with vertical. Okay. Any problem? Any difficulty is there? No difficulty is there, na? Easy problems, ma. Okay. So pause the video and write the solution. 3, 2, 1, go. Right. So this is the end of the today's lecture. I hope that you are understood man rain problems. Okay. Right. So maximum all types of problems that I bring today. Okay. So I hope that you are understood. Please practice important concept. Okay. Right. And we will meet on a next session, that is swimmer river problems or boat river problems. Okay, na? Right. So it's time to say signing off. Can I say signing off? Okay. So this is Rakesh Kanaganti signing off. Stay tuned. Jai Hind.